Right, hi there, welcome to video 4 an integration topic looking at definite integrals. Okay, now this is something that we'll go into a bit more detail, the why about it in the next video, but this one we're just going to look at the process of using a definite integral. So 3 things to consider here. Firstly, we want to be able to integrate as normal but not including the constant of integration. We want to be able to substitute limits into an integrated function and be able to evaluate limits successfully. Okay, so right now that probably won't mean very much to you, but by the end of the video that's the 3 things you need to be able to do. Okay, so here the difference between a definite integral and an indefinite integral, which is what we've been working on so far, is the existence of these things at the top and bottom of the integrand called limits. Now, taking the capital F of x as the integral of f of x, these limits will then substitute into the integral to give you a definite value. Okay, so this b and a will go into the integral to give you a definite value you can evaluate. Okay, so this is why it's called a definite integral, because it gives you an answer. The reason we don't need the constant of integration is because we are going to use the integral twice with a takeaway between them. If you include the c in both, you're going to end up with c take away c, which will cancel out. Okay, so this is a lot of mathematical notation. Essentially what we need to know is we're going to integrate and then take each of the limits and substitute them in. Top one first, take away the bottom one substituted in. Okay, so I'm going to show you 2 examples, we'll work through them and then we'll revisit the success criteria. Okay, so firstly you'll notice this is a definite integral because of the existence of the limits at the front. First thing we need to do is we need to integrate. So taking that 6x squared is going to be 6x to the power 3 divided by 3. Okay, we don't need the c, but what we are going to do for our notation is square brackets with the limits on the right hand side. Okay, now simplifying inside those square brackets, that 6 divided by 3 will just give us 2. And then we need to substitute our limits in. Okay, sorry, which I've forgotten from the side there. So top one first, so the 5 going in. So it's going to be 2 times 5 cubed. And then we're taking away the second one substituted in. So it's 2 times minus 1 cubed. Okay, then 5 cubed is 125, so that first bracket is going to be 125 times 2, which is 250, and we're taking away minus 1 cubed is negative 1 times 2 is negative 2. So 250 subtract negative 2 is 252. Okay, so we have an integral here as a definite integral, so we have a definite answer, 252. Okay, second one here. We've got an integral, again definite integral with the 3 and 1 being there as your limits. We need to integrate what's in there and substitute those limits in. Bit of a problem in that we can't integrate it as it stands, so we're going to split up our fraction, so x over x cubed and then 5 over x cubed, brackets, we integrate that all with respect to x. Still the issue, we tidy up those fractions, 3 to 1, so that's going to be x to the power minus 2 plus 5x to the power minus 3, and we're good to go for our integration. Okay, so that becomes square brackets there, x to the power minus 1 over minus 1 plus 5x to the power minus 2 over minus 2. Now, apologies, give me a second, that first square bracket shouldn't close where it closes. Okay, sorry about that, that's not fixed. So the square bracket should close after your integral with 3 and 1 as your limits. Okay, I'm going to rearrange this a little bit because I'm going to put a number in to use. So that first term is going to become overall negative with the x at the bottom with power 1. Second one will also be negative with 5 in the top by itself and 2 joining the bottom by the x squared. Okay, so I've integrated, I've rearranged so that the substitution becomes a little bit easier, and now I'm good to go for my limits going in. So firstly is going to be minus 1 over 3 for that x, minus 5 times 2 over 2 times 3 squared. Take away the second limit going in, so minus 1 over 1 minus 5 over 2 times 1 squared. Okay, and it's just a case of calculating this. So that'll be minus 1 over 3, subtract 5 over 18, take away minus 1 minus 5 over 2. Okay, doc, so just a bit of fraction work there. Minus 11 over 18. Take away negative 7 over 2. Okay, which becomes 52 over 18. Okay, so that's us get two definite integrals there to evaluate. The processes are the same for the integration, just miss out the plus c. Your limits go in first one, take away second one. Okay, so those are the three things we need to worry about. Being able to integrate is normal, but not including the constant of integration. Being able to substitute our limits in and then evaluate the limits successfully. And again, each of these will be marked as we're going through an exam paper. Okay, thank you very much.